If entropy records the cost of change, the next question is simpler but deeper. Why does change move in one direction rather than another? Nothing in the universe needs a goal in order to move. Motion does not require desire, planning, or intention. Motion happens because differences exist. Those differences are called gradients, and gradients are what give motion direction. A gradient is simply an imbalance, a difference in temperature, pressure, concentration, potential, or curvature. Wherever such a difference exists, motion follows. Heat flows from hot to cold. Charge moves from higher electric potential to lower. Fluids flow from high pressure to low. Matter follows curvature in spacetime. In every case, motion does not choose a path. It responds to a slope. This is why gradients matter. They replace purpose with physics. Consider heat. If one region is hotter than another, energy flows, not because heat wants to spread out, but because the microscopic motions that carry energy have more available pathways in one direction than the other. The gradient defines what transitions are easier. Motion follows the direction of least resistance, not because it is optimal in some abstract sense, but because other directions are harder to sustain. The same logic applies to chemical systems. Molecules diffuse from regions of high concentration to low concentration. This is not a decision made by particles. It is the statistical outcome of many random motions filtered by an imbalance. Where gradients exist, motion has a preferred direction. Where gradients vanish, motion slows and eventually stops. This is why equilibrium feels like stillness. When gradients disappear, there is no longer a reason for motion to continue in any particular direction. The system has exhausted its available differences. Motion doesn't stop because something prevents it. It stops because there is nowhere left for it to go. Gradients also explain why motion tends to be predictable at large scales, even when it is chaotic at small ones. Individual particles move randomly, but large collections of particles follow smooth flows. Rivers form not because water plans to carve channels, but because gravity creates a height gradient. Once a channel forms, it deepens, reinforcing the gradient and guiding future flow. Motion builds on itself, not through foresight, but through persistence. This idea extends beyond matter and energy. Information also follows gradients. Signals propagate where noise is lower. Computation flows along paths where errors are minimized. Even biological systems exploit gradients. Cells move toward chemical signals, not because they know where they're going, but because local differences bias motion in one direction over another. In every case, gradients act as direction without intention. This is an important point because we often smuggle purpose into explanations without noticing. We say systems seek equilibrium or try to minimize energy. But nothing is trying. These are shorthand descriptions for what happens when motion is filtered by constraints. Gradients do not pull systems forward. They make some transitions more likely than others. Once you see this, many mysteries lose their mystique. Why does energy flow outward from stars? Because temperature gradients exist between the star and space. Why does matter clump into galaxies? Because gravitational gradients guide motion inward. Why does time feel like it has a direction? Because entropy gradients make some transitions irreversible. The universe does not need a preferred future. It only needs differences that have not yet been erased. Gradients also explain why motion often accelerates rather than slows. When motion reduces resistance along its own path, it steepens the gradient it follows. Water erodes rock, deepening channels. Electrical current heats conductors, altering conductivity. Biological pathways become reinforced through repeated use. Motion doesn't just follow gradients, it reshapes them. This feedback is how complex structure emerges without planning. Motion follows gradients. Gradients guide motion. Persistence locks in paths that work. No blueprint is required. But there is a cost. Gradients do not exist forever. They are consumed by the motion they drive. As energy flows, gradients flatten. As differences disappear, motion slows. To maintain motion, new gradients must be created, and creating gradients requires energy and dissipation. This brings us to the unavoidable price of motion and structure. If gradients give direction, what pays for keeping them alive? To answer that, we need to talk about dissipation. My name is Charles Carroll. Thanks for taking the time to listen.